Greetings, Doctor. So we are from Group Agent B. We have NAVINDRAN, KUGANRAJ, and also me, KUGANES VARMAN. So today I'm going to present to you about hospital management system. So let me go straight for the introductions. So from here, we realize the healthcare industry has faced an outstanding challenges ever since the COVID-19 pandemic hits. So we have decided to develop a hospital management system that is aimed to optimize the use of the essential resources such as doctors, beds, and medical equipment. So in this project, we implement the deadlock avoidance safety algorithm, which is essential for managing resources without causing deadlock, which can disturb hospitals' operations and patient care. So we have implemented C++ program to simulate this algorithm. So the program will actually calculate the need for each process based on its maximum resource requirements and current allocation, where it checks if resources can be allocated without leading to a deadlock. So the user of the system will be able to update allocated resources, update max resources, and also update initial available resources.
Hello and good evening. I am Navindran, son of RAGHUPATHY, and my matric number is A22E60227. So today I will be explaining about the project for our operating system course, which is the deadlock avoidance using the safety algorithm. And the real life example we choose for our project is hospital management system. So for my part, I will be explaining about the problem statement and also the related work about the project. So for the problem statement, we choose the real life example, which is the hospital management system, because hospital management system often experience the deadlock when the processes like treatment, medication try to assess the shared resources, which are the bed, operating room, doctors, or the medical appliance. They will face this deadlock. So through this hospital management system, we can visualize the deadlock avoidance using the safety algorithm. So for our case, we choose the treatment as the process, and we choose three resources, which are the doctors, medical appliance, and also the bed. So the main objective of our project is to determine whether the hospital management system can be completed in a safe state or not. Safe, safe state means that there will be sequence of processes that use the allocated resources it needs to complete the task and release the allocated resources so that the process can use it to complete their task. We ensure that all the processes like the treatment or medication will be completed in a safe state. So this is a problem statement for our project. Next is the related work. For this project, deadlock avoidance, we choose the bankers. We have to implement the bankers algorithm, and there are two methods in bankers algorithm, which are safety algorithm and also the resource allocation algorithm. For our case, we choose the safety algorithm and related it to our real life example, which is the hospital management system. In previous research, in researches we conducted before, like the hairline system, we noticed that it's also similar to our project, which is a deadlock avoidance safety algorithm, where the in airline system, the processor is booking the flight or paying the money for the flight, and the resources are the seats, payment gateway, customer service like that. So they implement the safety algorithm to visualize the deadlock in the airplane system. So as the same same logic we implemented in our project, which is the hospital management system. So in hospital management system, there will be hospital safety algorithm for the hospital management system. There will be four matrices, which are allocation matrix, which is a 2D array, maximum matrix, which also a 2D array, available a 1D array, and need, which is also a 2D array. So that's all for my part. Thank you.
Hello, my name is KUGANRAJ. I will telling you guys about the abstract of the project. This project presents the design and implementation of a hospital management system utilizing the banker algorithm. The primary goal is to ensure that there is no deadlock happening in the system, as deadlock in the hospital system will be fatal. This approach aims to make sure that there is no process in the hospital that will wait endlessly for resources and risk the life of a patient. This project involves the creation of a simulation to demonstrate the banker algorithm action in mitigating deadlock. That is all for abstract. Hello, now we will go to the project management flowchart. So first we'll start the project by gathering the requirements. What will be the processes, what will be the resources, how much the maximum resource that a process could have, and so on and so forth. And then we go to the system design, where we do the flowchart of the system, and then we started coding it, and then we test it, and if everything is okay, we deployed it. So after deployment, we will do a feedback among ourselves. We'll see if the system is doing everything that it is intended to do. If it's not doing everything as is intended to do, we'll go back to the requirement gathering and we'll do all the steps again until we are sure that the system is working perfectly fine. After that, we'll go to the documentation, and that's all for the project. That's how the project flows. So next will be the hardware and software requirements. For the hardware requirement, a standard computer system with at least 8 GB of RAM and 120 GB of storage is good enough for the system. Anything that lower of this also would be good enough. This is where you get the optimal performance. For the software, we use C++ for the coding as a coding language to develop the coding and simulation for the bank algorithm. You also will need IDE, integrated development environment, such as the VS Code, for writing and testing the code. Lastly, draw.io for creating flowcharts and visual representations of the project. That's all for hardware and software requirements. Okay, now would be the collaboration of the team. So in this slide, I will talk to you guys about how we as a team collaborated together to make sure that the system or the project is a success. So for the first task, we did requirement gathering and analysis. This is assigned to all members. All of us need to identify the project requirements, understanding user needs, analyzing the feasibility of implementing the bank algorithm in the hospital management system. This is the task where we need to make sure that bank algorithm is indeed suitable for the hospital management system. For second task, is system design and flowchart creation. This was assigned to KUGANES VARMAN. His responsibility was designing the system architecture, creating flowchart, and defining the workflow of the hospital management system using the banker algorithm. And for the third task is a simulation development. This was assigned to NAVINDRAN. His responsibility was to write the C++ code to implement the bank algorithm, ensuring the code handles various scenarios and behaviors. So for the fourth task, this is testing and validation. It was done by me. I need to test the simulation and visualization to ensure it's working as perfectly as fine, and I need to validate the results and making all the necessary adjustment if there is any. For the fifth task, which was documentation and presentation, this was assigned to all members. Everybody will need to compile their project documentation, prepare final report, create the presentation slides, and ensuring all project materials are well organized and complete. For the last task, which was project management and coordination, this was assigned to KUGANRAJ. His responsibility was overseeing the entire project, coordinating between team members, managing timelines and deliverables, and ensuring the project stays on track. Without all of us, this project would not be a success. Thank you.
Okay, so now I'm going to explain about design implementation. First is start the program, and then it will display the number of processes, allocation, maximum, need, and also initial available resources. And then it will display the options, which are update allocated resource, update max resource, update initial available resource, and also exit. And then we ask for please select an option, and then if they choose the first option, which is update allocated resource, it will first ask to read process number, and then ask to input new allocations. And the second one, if they choose option number 2, it will update max resource. As usual, it will ask for to ask them to input 3, 2, 1. Okay, so now I'm going to explain about design implementation. First, we start the program and then it will display the number of processes, allocation, maximum, need, and also initial available resources. Then it will display the options, which are update allocated resource, update max resource, update initial available resource, and also exit. And then it will display please select an option. So first, if they choose the first options, it will ask them to input the process number and then input the new allocations. Second, if they choose the second one, update max resource, it will ask to input process number as well. And then now it will ask to input new max. And then as for the third one, to update the initial available resource, it will just straight away ask us to input the new available resource. And then at last, for the fourth one, option number 4, which is exit, it will exit from the system, and then now the system will check the system safety. So if the system is in safe state, it will display the safe sequences. If it's not in the safe state, it will display the unsafe message, and then it will end the program.
In our execution of our coding for the deadlock safety algorithm, and here this is our coding for this project. So first we run, we see the terminal. Okay, here this is our interface, and here how our group's coding is look. First, it will show the hospital management system in the main menu, and then the file process, and then it will show the allocation, maximum, and need resources values for these 5 processes. And then we also have this initial available resources 152 that we set in the coding before this. We set it here 152. Here, this is the initializing value for this, and then we have the interface to update allocated resources, update maximum resources, and initial available resources here. So if we enter 1, it will ask for the process number. So let's say I will change the process number 1. Okay, and then I will enter the new allocation number. Let's say I will enter the old one is 100. Now I will enter 234. 234. This is the example only. For update max resources, I will update. Max resources is for 175 for process 1. So I will change it for process 1. 2, 3, 4 also. And then updated initial valuable resources is initially is 152, and then I will update to 3, 4, 5, 6. So lastly, I will show the result of this project. If we enter number 4 to exit, it will show the results. So this is the results. Basically, it will show the 5 processes and the value of the allocation maximum need. So we see here, for example, I updated this process 1's allocation maximum value, right? So it will be updated to 234 and 234 for maximum value, and then it will update the initial available resources. So then it will show the process T0 executed without deadlock. For all the process, it will show the process is executed with deadlock or without deadlock. It will maintain this, and then it will also show our system is in safe state or not. It is if it is in not safe state, it will show system is not safe state, and then it is also if it is safe state, it will show the safe sequence here: T0, T1, T2, T3, T4. Basically, this is the results for our execution. Okay, basically this is the results, and as I say, it will show the process executed without or deadlock, and then it will show the safe state or not safe state and the safe sequence. Basically, this is the results. Then the discussion is the allocation means this represents the number of resources currently allocated to each processes. The maximum value is the number of resources each process need. The need represents the remaining resources each process still requires to complete its task calculated as maximum allocation. Okay, the output you provided demonstrate that used for the bankers algorithm to determine whether a system in a safe state and to find a safe sequence for executing processes. So basically, we ensure this hospital management system that in safe state and it will produce the safe sequence for these executing processes. So basically, this coding is for enhance and make the hospital management system in safe state by preventing the deadlock. We're using the safety algorithm to do this. Okay, for the conclusion, there is that the system becomes complex, resources in hospitals change quickly, and data will be very sensitive. And then the benefits are, and then we can enhance the patient treatment, and we can reduce the risk, and we also can save the cost by preventing this deadlock. And then the experience that we gain from this, uh, we get to know about how to work in a group, and then we work with existing hospital system. We enhance the system to apply the what deadlock prevention algorithm, and then lastly, we also know about the deadlock prevention and resolution by applying this project in hospital management system. Thank you. Thank you very much.